Namaskar. Welcome to Tapovan, where learning meets stillness. This is a calm space to learn deeply with code. In this series, we'll learn JavaScript, MERN stack, and the ultimate outcome is that we will end up creating impactful MERN plus AI projects for our resume and to get career outcome. In this very first bite, in today's lesson, we're going to start our journey into the world of JavaScript. And first thing that you probably need in a language is learn how to define variables. And in JavaScript as well, there are multiple ways to declare a variable, namely var, let, and const. Now you might have seen those web series and movies where there's a mystical forest and then there's a shapeshifter. They constantly change forms, they move freely, right? And then there's a sage who's focused, peaceful, bound by discipline. So in JavaScript, var is our shapeshifter. It can change and move across boundaries. Let and const, they are the sages. They respect the boundaries. They stay within the path. Right, with that analogy in mind, let us see some code in action. Let us start with some example. Let's create a variable function test var, and very quickly we'll define a variable var x equals to 10. The standard discussion that we do when we are discussing var. Okay, and then of course we'll have to call the function. What do we expect? This invocation will call the function. The first console log will print a value that is undefined. And secondly, we get the value as 10. Why is that? Why does x get the value undefined even before it is declared or assigned? We are declaring this variable and assigning a value of 10 at line number 3, my dear friend. But at line number 2, we are still able to access it. It's not breaking, remember, right? And it gets a special value known as undefined. In coming classes, when we discuss the internals of JavaScript engine and how it works, we'll discuss more on this, how it is parsed, how the memory is allocated for the variables, and the special value is assigned. Correct? For now, what I want you to understand is this behavior where the variable declaration is moved to the top of the function. That is known as hoisting. In coming class, you will be able to refine the definition of hoisting, but for now it is sufficient to understand that this variable x, the declaration was moved to the top of the function. Correct? Which is why you were able to access console log x and you get a value of undefined. And then the assignment happened at the appropriate line. Okay, I'm going to remove this. The next thing that we should keep in mind is the valid declared variables are function scoped. All right. So if I do something like this, let's say if true, and move this declaration and assignment inside the block, what do you think we'll get? Let us see this in the browser. We are still able to see undefined and 10. The behavior did not change. Correct? The behavior did not change. Why is that? Because var declared variables, they do not respect boundaries. That is what we discussed. Shapeshifter, moving freely beyond the boundaries. They only respect the function scope, which is why still the declaration moved to the top of the function code and you were able to get undefined and 10 just like before. Now this, my dear friend, creates a lot of bugs. This was creating a lot of quirks when people were working with JavaScript, which is why let and const were introduced, our sages. Now what happened was, If we declare the variable with let me have one more. Let's quickly print them. X and Z, correct? Let me duplicate, bring it down. Now what happens? This particular line prints 10 and 20, right? Nothing surprising over here. But what do you think will happen for this particular line? Let us see this. What we see, my dear friend, is it breaks. It gives a reference error. It is not able to reference X outside the block where we had defined, right? So my let and const respect the block scope. They stay within the boundary defined by the blocks, basically the parentheses, right? Your for block, your if block, your while block, correct? This is what makes it very predictable, which is why they were introduced. Okay, cool. Now let me discuss one more concept while we are at this particular discussion. The idea of temporal dead zone. Sounds very fancy, right? Right. The idea is pretty simple. If you try to access a variable just declared using let or const, and if you try to access it before they are declared, your code will break. Right. So if we try to access a variable before they are declared using let or const, it breaks, we get a reference error. Cannot access a before initialization. So does that mean, I'll tell you one thing, does that mean that variables declared with let and const are not hoisted? The answer is they are hoisted, but they are in a special memory state. Right, let us see this more clearly. Let me add a debugger and try to reload the application. Now what you see here is my execution is stopped at this particular line. It has still not reached console log A or let A equals to 5. A equals to 5, correct? Now, if you look at the scope, which gives us the variables which were identified with JavaScript engine, what do you see? That this little variable declared using let is present in a reserved scope which is defined by the name script, and you see the value, it says value unavailable. So the fact that the execution did not even reach the declaration and the variable a was present in the scope gives us the idea, indicates that the hoisting also happens for let and const, but we are not able to access or use them like as we do with the var declared variables. Right? So in short, let and const variables are also hoisted, but they are in a special state before declaration, which is known as temporal dead zone. Correct? So when do we use each folks? Const when you don't plan to reassign, when we don't have to reassign the variable. It's the sage sitting still. They'll not move. Second is using declared by let. Now reassignment, whenever you feel like you'll have to change the value of the variable, then we use let, right? But it still respect the block level discipline that we discussed. And var declared variables, they are like, whatever comes to mind, they do it. They're those kind of folks. They don't respect boundaries. It's the unpredictable shapeshifter. We stay away from such unpredictable beings. That is what it is. Okay? Now let's do some very quick questions to understand, to cement the understanding that we have done so far. Let's talk the first problem. Let's call it a name of phantom shadow. We have a variable var a equals to 1. Let's create a function mistake. Okay. And inside this function, let us try to print our variable a. Var a equals to 2. We're declaring it again. console.log a, and then I call the function mistake. Take a moment to answer this. Pause the video, take a moment to answer this. Answer it yourself and answer the reason along with the answer and give the reason along with the answer. Basically, what is happening, my dear friend, is when we are calling this function, this particular line will print the value as undefined. And then we get the value as 2. Why not 1? We declared the variable a equals to 1, right? But why does it still say undefined? Because my var declared variables are function scoped, correct? And what is happening here is that this variable a hoisting happens and it creates a shadow copy of the outer variable. Now this all of these were the reason why var usage of var was discouraged. All right, cool. Let us talk about the illusion of constancy. Now, I'm giving all these fancy names to the problems. These are just normal concepts that we want to discuss through these problems. Let's say we have a variable, Const river. The flow of that river is gentle. It's a gentle flowing river. Now, this is variable, if you notice, I've declared it with using the const keyword, right? This means I do not want this variable to be changed. Now tell me, my dear friend, is this allowed? Can I make this river go wild? The answer is yes. Can I make this river still by pointing it to a new object? Now, this is something which I cannot do. So, why can we change the river flow but not the river itself? The answer is the const locks the binding. The const will lock the binding but not the internals. Your reference, this river variable will point to the memory reference where this object is declared. It will always point to that memory reference. But what we are doing here, my dear friend, is changing the internals of the object. But what we were trying to do in this particular line was we are trying to change the reference itself, which is not allowed. Correct? In a world full of shapeshifters, may you be like Const, mindful, calm, and have strength to stay true to your boundaries. Thank you so much for walking few mindful steps with me today. Until next time.